The Kingdom of Bahrain continues to advance its position in the field of science and space technology. In recent years, the Kingdom has made significant strides in leveraging space applications to support national development. Through strategic initiatives and partnerships, the Bahrain Space Agency is expanding awareness of how space technologies can serve vital sectors. One of its initiatives is the organization of specialized workshops that bring together experts and government representatives. These platforms highlight the growing importance of satellite data in decision-making and planning. Advanced technologies now allow us to see the unseen through sophisticated imaging and data analysis. This has wide-ranging applications across infrastructure, agriculture, and environmental monitoring. Such efforts align closely with national priorities and long-term development goals. The Bahrain Space Agency recently concluded a specialized workshop titled Seeing the Unseen, highlighting advanced satellite imaging technologies and their real-world applications. The session brought together international experts and government stakeholders to explore how space data can support infrastructure, agriculture, and environmental sustainability in Bahrain. And to talk more about that, we are pleased to be joined here in the studio by the Senior Space Data Analyst at Bahrain Space Agency, Engineer Aysha Aljawder. Welcome, how are you doing today?
I'm good, how are you?
It's such a pleasure to have you. I'm very well, thank you so much. Now, first of all, I'd like to know a bit more about the main objective behind organizing this workshop at the Bahrain Space Agency.
Okay, first of all, thank you for the introduction and thank you for having me here today to discuss more about this workshop. So this workshop's main objective is to shed light on one of the important subfields of the space sciences, that is Earth observation and remote sensing. This subfield, which you may know from, you can deduce it from its name, is the monitoring of the Earth's processes, the land, the ocean, and the atmosphere through space technologies such as satellites. And these satellites are mounted by sensors, more commonly camera sensors, that enable us to gather this information about the Earth. So through this workshop, what we are trying to achieve here is to build national capabilities in the knowledge of this technology, as well as how to utilize this technology to help serve policymaking in various sectors in the kingdom.
Wonderful. And going back to the name, could you tell us why you chose to focus on the theme of seeing the unseen in this particular workshop?
So the theme, seeing the unseen, stems from the different camera sensors that can be mounted on the satellite, as I just mentioned. So, for example, the cameras that we know or that we use daily on our phones, that when we take a picture of something, we see the image in its true color, similarly to the way our visible eyes see them, because they capture it in the visible light. However, with satellites, we can expand the camera sensor capabilities to include further regions in the electromagnetic spectrum. So this can include regions further from the visible light, such as infrared, as well as the microwave regions. And the reason why we try to capture images in these regions, because they can provide us with a wealth of information about the objects, different types of objects on land, because the reflectances in these regions of the spectrum could signify different properties of these objects. To clarify this, I'll give an example. If we have a high reflectance in the near-infrared region, this indicates that this region is highly dense with vegetation and that the vegetation is healthy. So with this type of information, we can create policies or provide projects that could ensure the health of the vegetation, as well as to improve vegetation in other areas. So this is the theme of the workshop, and why we have decided to set it as Seeing the Unseen, to showcase how satellite technologies can help us see information that cannot just be seen by the visible eye.
Wonderful. And can you explain in simple terms what certain technologies are? For example, we have HSI, SWIR, and TIR.
Okay, so HSI, it's an imaging technology. It stands for hyperspectral imaging. And if we go back to the electromagnetic spectrum concept and seeing the unseen, what this imaging technique does is that it takes 100 to 1,000 layers, or we call them bands, of a specific region in the electromagnetic spectrum. So for one image, you would have 100 bands of that same image, and each of these bands, they would have a different reflectance value. So this could give us further information about the properties of that object. And this is very useful for that case. And in terms, as you said, the SWIR, it stands for shortwave infrared. It's a specific region in the electromagnetic spectrum, and it's also can be used for hyperspectral imaging. So you can do HSI on the shortwave infrared region. And this specific region specializes in the ability to penetrate different atmospheric conditions, and it can help also in the analysis of different building materials, soil properties, vegetation, and many others. The last acronym that you mentioned, TIR, it's thermal infrared. It's also a specific region in the spectrum, and this region deals with detecting the emitted heat from objects, and this capturing data in this region could really help us in developing applications related to land and water surface temperature.
Wonderful. And now I want to talk a little bit about the agricultural sector in Bahrain and in the wider region. How does satellite data support the agricultural sector in these regards?
Yes, so following the example that I gave about the vegetation health, you could also assess the health of vegetation through identifying crop water stress. There are also a variety of applications. I'm just going to give some examples. You could also analyze different soil properties, so you could understand soil moisture, salinity. This could help us in identifying suitable lands for agriculture, planting. There are also applications, especially with the HSI, hyperspectral imaging. You could even identify crop species from satellite images, because if you have a wide range of reflectances, each high reflectance value from hundreds or thousands of bands could indicate specific species. So you could use that to identify the species on land. Another application could be to understand the carbon sequestration capabilities of vegetation, and the list goes on. So all of these applications could really help us understand more the agricultural land in the kingdom and in other regions as well, and how we can develop projects to maintain and improve the sector.
And environmental sustainability was a key focus. Could you highlight how space technologies could help address environmental challenges?
Okay, so space technologies, its main purpose is to provide data to either support the policy or the project. And there are two main ways where this data could help developing policies or starting different projects. First is to provide assessment of the current state and how we can use the current properties or materials in order to develop projects to help environmental challenges. And the second way is to monitor the progress of these policies and projects. An example of how this could work in the Kingdom of Bahrain related to one of the environmental projects we have here is, for example, the National Afforestation Project. If we're going to look at it from the first way, we could first analyze the current green coverage in Bahrain, could help us understand where are the areas that we need more planting or vegetation. The second way, we could also analyze the suitable locations to identify the regions to plant them based on the soil properties. So this is how data supports in that way. And the second way is to monitor the progress of the implementation of that plan. So you would see the progress of the increase of green coverage as the years go by, as well as you could also see its impact on the environmental elements. So you can see its impact on the temperature or the air quality. So this is how Earth observation data or satellite data could have a real hands-on impact on projects that deal with environmental sustainability and dealing with the challenges of environment.
And this workshop also featured, it was delivered in collaboration with Earth Eye Space. Could you tell us a little bit about that collaboration?
Yes, so collaborations with experienced organizations such as Earth iSpace are crucial to ensure that the most updated or recent and relevant information regarding space technologies are being shared with the key stakeholders in Bahrain, especially with the capabilities of Earth iSpace and their data provision platform and analyses. Our participants in the workshop were able to visually see how the data is being visualized in the platform and the different types of analyses that can be done through that data.
And the workshop saw strong participation from government entities. How important is this cross-sector engagement?
So we had around 8 different sectors that have participated in the workshop. Among them were environment and agriculture. We had from urban development as well as security. Almost 90% of the participants have demonstrated that they have gained knowledge on how they can utilize this data in their respective sectors, and they've seen that it's relevant to the work that they do, which is the aim of the workshops and any awareness program that we do. We try to showcase that you can utilize this data in order to support your own work in your own field.
And what role does artificial intelligence play in analyzing satellite data and images?
So artificial intelligence, of course, has touched upon all sectors. So of course, it also impacts the space sector and Earth observation. And the way that it's integrated into the analysis of satellite data is in 2 ways, either through image processing or we call it computer vision. So through image processing, the satellite data the images would be enhanced in order to improve the efficiency of further analyses after. With computer vision, this will involve detecting or classifying specific regions in an image, and based on that we can develop applications for detecting changes or anomalies or even prediction of different occurrences. And the integration of artificial intelligence here is efficient for the processes of satellite image analysis, because it speeds up operations, and it also ensures consistent output for different acquisition dates of satellite images, because there's a huge amount of data.
Wonderful. And lastly, I'd just like to ask you, how can satellite data contribute to better policy making, strategic planning, as well as achieving the national and international goals, for example, like Bahrain Vision 2030, and the Sustainable Development Goals? Yes,
so satellite data is important for any geospatial related data-driven decision making. So as a policymaker or decision maker, you need to have full awareness of all the properties of the land or the atmosphere of the ocean in order to be able to develop policies and projects that have a consistent stream of input and factual data. So if you have a consistent stream of data and analyses, it could help in also achieving or monitoring the progress of different goals, because you would first be able to assess the current status of that goal. You could also maintain different projects and also monitor it all through satellite data. So this is how satellite data plays a role in policy making and decision making, as well as monitoring different types of goals, because in order to understand if you've achieved a goal or not, you need to have the data to back it up, and satellite data is really useful in that case.
Absolutely. I'd like to thank you so much for telling us about this workshop, and to thank you so much for your time and expertise. Thanks for joining us.
Thank you so much for having me.